Hi, everyone. Today we are talking about random samples in statistics. So, in the first section in this chapter, we talked a lot about statistics in general and the process of using a sample to generalize to a population. Today, we want to really tune in on that concept of a random sample because there's a lot of rules that we have to follow to make sure that our sample is truly representative of our population. If we choose a bad sample and it doesn't represent our population, then we're making some bad inferences. Okay, this is what's called inferential statistics when you're trying to um, expand your thoughts or expand your findings onto the entire population. So we want to make sure we choose that sample well. So this first video is going to focus just on what's called a simple random sample. And the definition of a random sample is, a sample, so it's a group taken out of the population. But the important piece of this is that every individual is equally likely to be chosen as part of that sample, okay? And every separate group is equally likely to be chosen. So the likelihood of choosing these five people versus these five people, there's no difference between the two. Okay, so that's what it means to be a simple random sample. So this first question kind of just focuses on the concept of that random sample. Then we're going to talk about ways to find it and do some simulations with it. So looking at the Colorado State Lottery, you pay $1, you choose any six numbers from 1 through 42. If your group or if your group of six numbers wins, you win $1.5 million. Simple enough, right? So in this process, if you're thinking about the lottery and they're like drawing, numbered balls out of a bin, is the number 25 just as likely to be selected as part of the winning group as the number 5? Well, if each one of those has a 1 in 42 chance of being chosen, then yes, I would say, and this is some probability notation here, but the probability of getting a 5 is exactly the same as the probability of getting a 25, as long as there's only one of each of those in the bin. And the way this is described, there would be. So is it possible for all six numbers chosen to be even? Sure, because any subset, this is a totally random sample, right? So any subset of six, any group of six is just as likely to be chosen as any other group of six. So a group of six where all six were even, yeah, that would be possible. These next two questions are sort of interesting. So let's suppose your friend always plays the numbers 1, 2, 3, 4, 5, 6. So the first question is just, could she ever win? All right, if she chooses those numbers. Is it possible for this set of numbers to be your lotto numbers? Okay. You might want to look at that and say, well, that's pretty unlikely that your lotto numbers are going to come out 1, 2, 3, 4, 5, 6. But it's not any more unlikely than any other set of six numbers, right? If each one of these numbers has the same probability as everything else of being drawn, yes, she could win. Okay. And again, it's unlikely, but it's equally unlikely for any group of six numbers to win. So let's say you choose your numbers by basically simulating the lottery. You're going to put 42 numbers in a hat and draw them out one at a time. Are you more or less likely than your friend to win? Well, the group of six numbers that you come up with is equally likely to be chosen as 1 through 6. And I know that feels weird, but it's true. Okay? So I would say equally likely here. And that kind of comes back to this idea that every sample or every group of six has an equal chance of being chosen for the lotto. Okay, so let's talk about some ways that you can find a truly random sample. And generally, this involves some form of making things numerical. So obviously, in the lottery situation here, you're already working with numbers 1 through 42. If you were trying to randomly choose students, you could maybe use like student ID numbers, for example, or excuse me, if I wanted to use the students in my class, I could number them 1 through 30. Okay. And then there's a couple different tools you could use to randomly choose numbers. So there's kind of the old school draw from a hat. And I don't know why we always chose a hat to use instead of any other receptacle. Okay. But basically, and I guess you could do this with names of people as well. So if I was choosing people from my class, I could write their names on slips of paper and draw those from a hat. They wouldn't have to be numbers. Um, but a lot of the times we convert things to numbers in math. So there's the draw from a hat. Okay, that's a physical, like choosing things out of a selection. There is something called a random number table, and we're not going to get into that in this format when you're doing this via video. Um, if you need to know that in AP Stats, and I'm honestly not sure if you do or not, but I'm sure they will show it to you and you'll pick up on it just fine. Okay. You can use a random number generator. That can be found on your calculator. I'm sure there's other technological tools too, like you could go online and just search for random number generator and you can find things that will randomly choose things for you. Um, so those are going to be the big three to kind of focus on. And I'm sure there's other ones that are kind of subgroups of those. The one thing that you want to stay away from, and I'll explain why in just a second, but you never want to choose numbers or items off the top of your head. Okay, so here's what I mean by that. In this first example, we're going to use a random, well, we're not going to use the random sample table. We're going to use a generator, okay? And we're going to just come up with 10 random numbers. And so some of you might look at that and go, really? I could have just made up 10 random numbers. But when you are choosing numbers randomly in your head, you don't necessarily pay attention to this thing where every individual has the same likelihood of being chosen. And here's what I mean by that. When you're trying to be random, you are more likely to try to choose numbers that are spread out from one another. So if your first random number that you choose is 12, chances are you're not going to allow yourself to choose 13 because you feel like that's not random, right? Those are two numbers right in a row. But 13 needs to be just as likely of being chosen as any other number that you could come up with off the top of your head. So even though I know the list of numbers we're going to come up with, you could just make them up. You really have to resist the urge to just make them up. You want to use some sort of tool to ensure that you're truly being random. Okay, so let's suppose we have, maybe we're a used car salesman, and we're going to pick 10 cars randomly off our parking lot to park up front for the display. Okay, so we want to randomly choose 10 cars. So my first step would be to number the cars somehow. And maybe I have some sort of database or something where they're already numbered. Okay, so that would be kind of my first step. And then here's how I can do this using a calculator. And again, I'm sure there's other technological tools that will do this for you. But we're going to go to the math menu. And then we're going to go all the way to the right to probability. Okay, and we want this one here. This is random integer. Okay, so option number 5. Now, I'm going to just leave that there for just a second. So you are choosing random integer. And then in the parentheses here, you want to give the boundaries. You want to choose random integers between what and what. So if we're working with 80 cars, I want to say we're going to go between 1 and 80. Okay, so in my calculator, I'm typing in 1, 80. I hit enter, and what it's giving me here is a random number chosen between 1 and 80. I can just hit enter again, and it'll give me another one. Enter again, enter again, enter again. Now notice right there is that thing I was talking about. 58 got chosen, so did 59. Now, after I chose 58, 59 should have been just as likely as anything else, right? But if you were choosing these numbers yourself, it's likely that you would stay away from that 59, and that's changing up the probability a little bit. So basically, you would use this tool and just hit enter 10 times. Okay? And those are your 10 cars that you're going to choose to put up front in the display. And if you're doing it on your calculator, it's quite likely that you don't get the same list of numbers I do. Okay? All of us are going to have different sets of numbers because it's supposed to be random, right? That's the whole idea here. So you may have a totally different list than I do, or someone else that does the same assignment. But these represent 10 random cars or 10 random numbers chosen between 1 and 80. Okay? So that's the idea of using a random number generator. It's simple, but it's very, very useful in terms of simulations. So I've used that word a couple of times now, simulations. Let's look at what it actually means. Simulation is the representation of a real life situation using numbers, random numbers, okay? And so what we just did there with me typing numbers into a calculator and hitting enter, that was a simulation of me going and choosing cars out of a parking lot, okay? I wasn't physically walking around the parking lot randomly choosing cars to drive up front. I was using a calculator and the numbers 1 through 80 to represent the cars, okay? Some other simulations you can do involve rolling dice or flipping coins. Those are sort of kind of hands-on simulations. But it's basically just making, like representing an event mathematically instead of physically doing it, okay? So in this next example, we're going to do a simulation. So it says a coin is being tossed 10 times, but instead of actually tossing a coin 10 times, we're going to do a simulation of tossing a coin 10 times. So use a random number generator to perform a simulation of this situation. So what I'm going to do is I'm going to just have my random number generator pick between two random numbers. There's two outcomes of tossing a coin, right? So I'm going to say that one is heads and two is tails. So I'm going to use my random number generator. So math, probability, random integer, but this time I'm going to have it choose between just 1 and 2, okay? And I'm tossing this coin 10 times again, so that means I'm hitting enter 10 times. So that would be heads, tails, heads, tails. That's not feeling very random. There we go, okay? So if I hit that 10 times, that represents those 10 coin tosses. And now I lost track of how many I did here. Let me start again. So that would be tails, 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 heads, heads. Tails, heads, tails, heads, tails. Okay? So that is a simulation of me tossing a coin 10 times. I didn't have to go find a coin and toss it. I could use my calculator to do it. Another way you can do things like that, by the way, is we could have had it go between like 0 and 9, let's say, just single digits, and go evens are heads and odds are tails. We would just want to make sure that whatever we set up, there's an equal likelihood of getting heads and tails. Okay, so you could go evens and odds. You could go numbers higher than 5 or 5 and above or less than 5 kind of thing, just as long as it's two things that are equally likely to happen. So suppose you performed another simulation using your calculator. Would you get these exact same outcomes? Okay. And then the next question is, could you get the same outcomes? So I would say it's not real likely that I'm going to get the exact same pattern again, but is it possible? Sure, because every sample is equally likely to be chosen every time, okay? So I would just answer this simply with something like not necessarily, but possible. Okay, so that kind of gives you the main idea behind random sampling, okay? And really want to drive home the point that when you're doing true random sampling, you have to make sure that everything and everybody in the population you're trying to represent is equally likely to end up in that sample right along with you, okay? If you're excluding parts of your population, then you can't make a generalization about your population. Okay, hopefully that was helpful. There is a second part to this video where we get into some more specific types of random sampling, so stay tuned for that.